Quantum theory. It's the study of small physics, and it holds so many possibilities for our view of the universe. What if I told you that what you see isn't actually what exists? That by observing the universe, you are actually limiting all possibilities and outcomes by collapsing particles. Well, particles actually exist in all states at once, as described by the superposition principle. So imagine me as a particle. If I can exist here, or like this, and here, or here, I exist in all of these states at once.
What is this?
Intel observe, that is.
Who are you talking to?
You see, particles exist in all states at once until measured or observed, which forces them to collapse into one single state. In the 1930s, one of the founding fathers of quantum mechanics came up with a thought experiment. He knew that subatomic particles could exist in this state. So he thought, why couldn't larger particles or groups of particles? And so he came up with this little experiment. You throw a cat in a box, along with a radioactive substance, Geiger counter, and a vial of poison. The radioactive substance has a 50-50 chance of decaying, and thus setting off the Geiger counter to release the poison. This means that the cat has a 50-50 chance of dying. Since the atom exists as both decayed and not decayed, the Geiger counter is both set off and not, which means that the cat is both alive and dead. And until you look into the box, the cat exists in both states. Now, this experiment has opened ways to many different interpretations of physics, one of the most famous ones being the Copenhagen interpretation of physics devised by Niels Bohr and Werner Heisenberg in the 1920s. This interpretation states that microscopic reality is created by observation and that looking collapses the probabilistic wave function. Now, Shrodinger originally came up with a cat-in-a-box experiment to prove their interpretation false on a more practical scale, but many people saw this experiment as further proof of the Copenhagen interpretation. Another famous interpretation is the many worlds theorem, in which universes constantly divide and each choice and its counter-choice lives out in its own world. Of course, there are countless other interpretations of physics, including the Bohm interpretation, in which the universe is an entangled whole, and the transactional interpretation, in which the future affects the past. But the deeper we go, the less we know. One thing's for sure, though, curiosity did, in fact, kill the cat.